Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video, we will learn how to prove that a complex number is real or pure imaginary. Given the complex number z equals a, where a is a real number, So when we see z equal real number, we say that z is a real number. What can we say about z bar? Z bar also equals a. What do we conclude? Z bar equals z. If z equals z bar, we conclude that z is a real number. If a positive argument of z equals how much? 0 plus 2k pi. If a is positive, z equals a positive number. Positive here, like this. Argument of z equals 0 plus 2k pi. Here, or we can rotate complete revolution, and we still here on the semi-positive line x-axis. If a negative, then the image of the complex number is here on the negative x. In this case, the argument of z equals pi plus 2k pi. Pi plus 2k pi, and we stop here. If a is different from 0, it means the image is here or here. Then the argument is either 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. Then argument of z equals k pi. Conclusion: a complex number is real if and only if. So when the imaginary of a complex number is 0, then the complex number itself is 0. Z equals z bar. When z equals z bar, it means that z is a real number. Z equals 0. If z equals 0, z is a real number. And if z different from 0, we prove that argument of z equal k pi. When z different from 0 and argument of z equal k pi, then z is a real number. The image of z belongs to x prime x. When the image belongs to x prime x, then the complex number is real. How to prove a complex number is pure imaginary? Pure imaginary, given z equals ia such that a different from 0, when we see z equal ia, a different from 0, we say that z is pure imaginary. For example, z equal 3i, pure imaginary. Z equal 7i, pure imaginary. Calculate z bar. Z bar equals minus ia. Z bar equals minus ia. If a positive, argument of z equal pi by 2 plus 2k pi. If a positive, it means the image of z belongs to the positive y, and the argument of z equals pi by 2 plus 2 pi, pi by 2 plus 4 pi, pi by 2 plus 2k pi. And if a is negative, the image of the complex number is here on the negative y. The argument of z in this case is equal to minus pi by 2 or minus pi by 2 minus 2 pi, minus pi by 2 minus 4 pi, and so on. Okay, or like this, minus pi by 2 plus 2 pi minus pi by 2 plus 4 pi minus pi by 2. minus pi by 2 plus 2k pi. Minus pi by 2 plus 2k pi if a is negative. And if a is different from 0, we know only that a is different from 0, a may be positive, may be negative, then the image of the complex number may be on the positive y or in the negative y, and in this case the argument of z is equals to pi by 2 plus k pi. Pi by 2 plus pi here, plus pi on the y positive, plus pi on the y negative, plus pi, it means pi by 2 plus k pi. So how to prove that a complex number is pure imaginary? First of all, real of z equals 0 and z itself different from 0. Or we can say real z equals 0 and imaginary of z different from 0. If real z equals 0 and imaginary of z equals 0, the complex number itself is 0 real. So real z equals 0 and imaginary of z equals 0, or the complex number itself is different from 0. Z equal minus z bar. Z equal minus z bar with z different from 0. With z different from 0. 3. We prove that z different from 0 and argument of z equals pi by 2 plus k pi. Pi by 2 plus k pi. When argument of z is pi by 2 plus k pi, then the complex number is pure imaginary. Or the image of the complex number belongs to the y prime y deprived of O. Or the y prime y deprived of O. Because at O the image is, the coordinates of the image are 0, 0. It means that the complex number equals 0 real. Exercise. Given the complex number z equal x squared minus y plus iy plus 1, where x and y are the coordinates of a variable point m in orthonormal system. Write z in trigonometric form if m of coordinates minus 2, minus 4. It means x equal minus 2 and y equal minus 4. Substitute x minus 2, we get 4 minus 1 is 3. Y equal minus 4, minus 4 plus 1 minus 3. Z equal 3 minus 3i. How to write the z in trigonometric form? We have to calculate its modulus and its argument. Modulus of z equals radical 3 square plus minus 3 square equals 3 radical 2. Cosine, if alpha is an argument of z, then cosine alpha equals how much? Real over modulus, and sine equals imaginary over modulus. Real is 3 over modulus over 3 radical 2 equal radical 2 over 2. Sine alpha imaginary of z over modulus of z minus 3, so minus radical 2 over 2. When we had the minus here, radical 2, radical 2, radical 2, radical 2, then the angle is pi by 4. And since we have minus here, so we are in the fourth quadrant, then alpha equals minus pi by 4. And z equals modulus cosine minus pi by 4 plus I sine minus pi by 4. Modulus 3 radical 2. Find the coordinates of m when z equals 8 minus I. 8 minus I, we have to find the coordinates of m. We know that z equals x squared minus 1 plus iy plus 1 equals 8 minus I. We can calculate x and y. X squared minus 1 plus iy plus 1 equal 8 minus I. So x squared minus 1 equals 8 and y plus 1 equals minus 1. Minus 1. Real part here x squared minus 1, here 8. They are equal. Imaginary part y plus 1, here minus 1, they are equal. So x equals 3 or x equals minus 3, y equals minus 2. Hence the point m of coordinates minus 3 minus 2 or 3 minus 2 or minus 3 minus 2, because we have two values of x and one value of y. 3 minus 2 minus 3 minus 2. Find the locus of m when z is pure imaginary. Z is pure imaginary if real Z equals 0 and imaginary of Z different from 0. Real of Z is x squared minus 1, imaginary of Z is y plus 1. Real of Z equals 0 leads to x squared minus 1 equals 0, x equals 1 or x equals minus 1. Imaginary of Z different from 0, y different from minus 1. Where does the point M move? X always equals 1 or minus 1 and y different from minus 2. Then the locus of M is the union of the two straight lines of equations x equal 1, x equal minus 1. Deprive the points of coordinates 1 minus 1, minus 1, minus 1. Union of two straight lines. It means either on the straight line of equation x equal 1 or on the straight line x equals minus 1. Exercise 2. Given the complex number z equal 3 cosine 5 pi by 6 plus I sine 5 pi by 6. Here we have a positive number, cosine angle plus I sine same angle, then this is the trigonometric form of z. This form is the trigonometric form of z because here we have the same angle and positive number. Modulus cosine angle plus I sine same angle. Write z bar in trigonometric form. What is z bar? We know that the image of z and the image of z bar are symmetric with respect to x prime x. So if the argument of z is 5 pi by 6, symmetry with respect to x prime x, it will be minus 5 pi by 6. Or we can say that z bar equals 3 cosine 5 pi by 6 minus 3 sine I sine 5 pi by 6. Because z bar, we changed the sign of the imaginary part. How to get rid of the minus here? Minus, because we should have cosine angle plus I sine same angle. So we introduce the minus into the sign. We get sine minus 5 pi by 6. Sine minus 5 pi by 6 is exactly minus sine 5 pi by 6, and also cosine minus 5 pi by 6 equals cosine 5 pi by 6. Then minus alpha, if we use the angle minus alpha, we get rid of this minus. We obtain the trigonometric form of z bar. Okay, or we say that the image of z and the image of z bar are symmetric with respect to x prime x. If argument of z is alpha, argument of z bar is minus alpha. That's same. Write z bar in algebraic form and deduce the image of z. Z bar in algebraic form. 5 pi by 6 equals 5 pi minus pi over 6 equals pi minus pi by 6. Cosine minus 5 pi by 6 equals cosine 5 pi by 6 equals cosine pi minus pi by 6. Here we are in the second quadrant, minus cosine pi by 6 minus radical 3 over 2. Sine minus 5 pi by 6, sine minus alpha equal minus sine alpha. Sine pi minus pi by 6, we are in the second quadrant, sine is positive. Sine pi minus pi by 6 is sine pi by 6. We still have minus sine pi by 6 equals minus half. Z bar equals 3 into minus radical 3 over 2 minus half I equals minus 3 radical 3 over 2 minus 3 over 2I. So Z equals minus 3 radical 3 over 2 plus 3 over 2I. Then the coordinates of the image of Z is minus 3 radical 3 over 2, 3 over 2. Write minus 2Z in trigonometric form. Minus 2Z equals minus 2Z, so we have to multiply Z by minus 2, then minus 6. Minus 6. This form is not the trigonometric form because here we have negative number. So we have to introduce the minus inside the brackets. So we have here minus cosine 5 pi over 6 minus I sine 5 pi over 6. How to get rid of the minus in both cosine and sine? By making use of pi plus alpha. Pi plus alpha in the third quadrant, both sine and cosine are negative. So cosine pi plus 5 pi over 6 plus I sine pi plus 5 pi by 6. Pi plus 5 pi by 6, this is 11 pi over 6. Here also 11 pi by 6. Positive number, cosine angle plus I sine same angle, which is 11 pi by 6. Then this is the trigonometric form